Here's the second example. We've got two vectors. One is minus 3, 5. The vector I'm calling A, vector B, I'm saying is 4, minus 2. The program I use to create these vectors notes them using commas. Now, what you're going to be asked in the exercise I've set is to verify these angles. Get used to using the dot product method. Don't calculate the third side and use the cosine rule, because that can be difficult when you come to doing 3 dimensions. It's not impossible, it's relatively straightforward, but we'll use the dot product. So we're going to use the fact that the cos of the angle between them is the dot product of the two vectors divided by the modulus product of the two vectors. And I will put together a video showing why this is true. Dot product is multiply the I parts and the j parts. The reason the I times I is, if you actually think about what you're doing, if you do I times I, you're looking 0 angle, and that is cosine of 1, of 90 degrees, of 0 is 1. If you were to do I times j, these two vectors are at right angles, the angle between them is going to give you a cosine of 0. So at the moment, with the dot product, you multiply just the I parts, the j parts resolve to 0. Okay, just a little thought about that. An I part times an I part equals 1. A j part times a j part equals 1. An I times a j equals 0 using this dot product. And keep saying dot product. There's another thing called the cross product, or the vector scalar product, the vector product, and that gives us a vector that points away. It's beyond the scope of P4, but the dot product actually gives us information about the angle between the two vectors. So multiply these two numbers together on the top, it gives me minus 12, and I add to that the 5 times minus 2 is minus 10. Divide that by the square root of 9 plus 25, so 34, multiplied by the square root of 20 again. Put those numbers into a calculator. So got the square root, now we need the calculation. Now we need to convert that by doing shift cos of that answer minus 0.84, and let's inverse cos that answer, and it gives me 147.53. So we're verifying these angles. These have actually been shown.